When a wire carrying current is placed in a magnetic field, the wire will be affected by magnetic force, which can be calculated by using the following formula. FB equal ILB sine theta. FB is the magnetic force in Newton, I is the current in ampere, L is the length of wire in meter, B is the magnetic field strength in Tesla, and theta is the angle between L and B. Okay, to find the direction of the force acting on the wire, we use the right hand rule, where the direction of forefinger represents the direction of the magnetic field, the direction of the thumb represents the direction of the wire length vector, and the direction of palm of the hand represents the direction of the magnetic force as shown in the following figure. So here, the direction of the four fingers is following the direction of the magnetic, and the direction of the thumb is following the direction of current moving in wire. So the direction of palm of the hand will be the direction of the magnetic force. The angle between force and B or force and L will be 90 degrees. Okay, let's answer some question. Example 5. In the following figures, different wires carrying current placed in magnetic field. Determine the direction of the magnetic force acting on the wire. For the first case, we use the right hand rule. The direction of magnetic field is to the right. This one B. And the direction of L, or we can make it more easy, the direction of current also to the right. The angle between these two vectors is 0. So sine 0 is 0, so there will be no force. So here the force FB will equal 0. This means no force. Okay. The second case. The direction of magnetic field is positive Y. This one B. The direction of current is positive X. The angle is 90 degrees. So the direction of the force will be positive Z, which means dot or positive Z. This one, the direction of the magnetic force acting on the wire. In the third case, the direction of magnetic field is negative Y. This one, the direction of magnetic field. The direction of current is to the right. The angle is 90 degrees. To know the direction of the magnetic force, we use our right hand. So it will be inside the page. Inside the page means X or negative Z. For the fourth case, the direction of magnetic field is to the left. The direction of the current is to the right. So the angle between magnetic field and current is 180. Sine 180 is 0. So there will be no force. Here FB will equal 0. For the fifth case, the direction of magnetic fields is the positive Z-axis. The direction of current is to the right, is the positive X-axis. The angle between these two is 90 degrees. To determine the direction of force, we use our right hand. So the direction of force will be to the negative y-axis. This one to the negative y-axis, mean down. Okay. For the sixth case, this is the direction of magnetic field, and this is the direction of current. The angle between magnetic field and current is less than 90 degrees. So we use the right hand rule. The direction of magnetic force will be positive Z or outside the page. This one, the direction of magnetic force. Here the direction of B in this direction, the direction of current is to the right. So here the angle is more than 90 degrees, and we use the right hand rule to determine the direction of force, which will be inside the page or negative Z. For last case, the direction of current is to the right and the direction of magnetic field is inside the page. So the direction of force will be positive Y. This one, the direction of FB. Okay. Example 5. Depending on the values in the figure and knowing that the wire length is 0.5 meter, find the magnitude and the direction of the magnetic force acting on the wire. Okay, FB equal I B L sine theta. So FB will equal I is 2 ampere. B is the magnetic field is 0.2. L is the length, which is 0.5 multiplied by 0.5 sine theta. The angle between current and magnetic field direction is 90 degree. So we say here 90 degree. 2 multiplied by 0.5 is 1. 1 multiplied by 0.2 is 0.2. Sine 90 is 1. So the answer will be 0.2 Newton. The direction of magnetic force, we use our right hand. The direction of current will be the direction of the thumb. The direction of magnetic field will be the direction of forefingers. So the direction of force will be positive Y. So this is the direction of the magnetic force. It is important to know that here, if we follow the current direction, which is positive charge, we use our right hand. If we following the electrons movement direction, we use left hand, or we just say the opposite of right hand. Example 6. Depending on the values in the figure and knowing that the wire length is 20 centimeter, this one need to convert to meter, find the magnitude and the direction of the magnetic force acting on the wire. From the figure, it's clear that the direction of current is inside the page. So the wire is perpendicular with the page. So here, FB will equal I B L sine theta. We use the same formula. If we don't know the length, then we can find the force per length. But here, because we know the length, so we can use just this formula. I is the current, 2. B is the magnetic field strength, which is 0.2. L is the length, which is 20 centimeter. 20 centimeter. We know that each 1 meter have 100 centimeter. So we convert from centimeter to meter. This 1 meter. 1 meter have 100 centimeter. So centimeter with centimeter cancel. 0, 0 cancel. So it will be 0.2 meter. So L is 0.2. The angle between current, which is positive X, and negative Z with magnetic field, which is positive X, is 90 degree. So sine 90 degree is 1. So here 2 multiplied by 0.2 is 0.4. 0.4 multiplied by 0.2 will be 0.08 Newton. To make it more easy, 2 multiplied by zero point 0.2 mean 2 divided by 10. 0.2 also 2 divided by 10. So the answer will be 2 multiplied by 2 is 4, multiplied by 2 is 8, 10 multiplied by 10 is 100, so it will be 0.08. Okay, now the direction of the force. Here we use our right hand, so the direction of magnetic fields is to the right. The direction of electric current is inside the page, so the direction of magnetic field, the direction of magnetic force will be to the down, this one FB, negative y axis. So here, negative y axis.